For centuries, the orbits of the planets around the Sun have inspired awe, curiosity, and debate among scientists and philosophers alike. While their current orbital patterns are well understood, the story of how these celestial orbits came to be is far from straightforward. Over the eons, the orbits of the planets have evolved significantly, shaped by forces both internal and external to our solar system. A groundbreaking new theory proposes an extraordinary catalyst for this evolution: a massive interstellar visitor, possibly 2 to 50 times the mass of Jupiter, that passed through the solar system and left its gravitational fingerprint on the orbits of our planetary neighbors. The early days of the solar system. The solar system began as a swirling disk of gas and dust surrounding a nascent blazing sun. Over time, gravity and angular momentum orchestrated this chaotic material into a relatively flat plane where the planets began to take shape. In this primordial environment, the orbits of these young worlds were circular and coplanar, a hallmark of the conservation of angular momentum. But these tranquil beginnings were not to last. As the planets grew, their interactions with the surrounding protoplanetary disk, along with gravitational pulls from each other, triggered migrations both inwards and outwards. These migrations weren't just incremental adjustments. They were tumultuous journeys that reshaped the architecture of the solar system. Gravitational interactions sometimes increased a planet's orbital eccentricity or inclination, while others had dramatic consequences, such as the ejection of nascent protoplanets into interstellar space. Tidal forces from the Sun added further complexity, subtly altering orbital shapes and orientations over time. Enter the interstellar wanderer. While protoplanet ejections and planetary migrations are well-documented phenomena, recent evidence points to an entirely different player in the cosmic ballet: interstellar visitors. The first confirmed example of such a visitor was Oumuamua, discovered in 2017. This elongated, pancake-shaped object exhibited unusual acceleration as it passed through the solar system, likely driven by outgassing or other non-gravitational forces. Although Oumuamua itself was too small to affect planetary orbits, it provided a tantalizing glimpse into the possibilities of interstellar interactions. Now, a team of researchers led by Garrett Brown of the University of Toronto has proposed that a much larger interstellar object could have passed through the solar system during its formative years and profoundly affected the orbits of the gas giants. According to their study, such an object, with a mass between 2 and 50 times that of Jupiter, could have disrupted the delicate gravitational balance of the young solar system. Passing within 20 astronomical units of the Sun, closer than Uranus's current orbit, and traveling at a hyperbolic excess speed of less than 6 kilometers per second, this massive intruder could have exerted enough gravitational force to alter the planet's eccentricities and inclinations in a way that matches current observations, a theory based on simulations. Using sophisticated simulations, Brown's team tested various scenarios involving interstellar objects of different masses, speeds, and orbits. Their calculations showed that there is a 1 in 100 chance that an interstellar visitor of this size could produce the orbital configurations we observe today. These odds, while small, are far better than those associated with alternative explanations, making this theory one of the most compelling to date. The researchers also showed that such an encounter could explain anomalies in the orbits of the gas giants, Jupiter, Saturn, Uranus, and Neptune, that other theories have struggled to explain. The eccentricities and inclinations of these planets suggest a history of significant gravitational perturbations, but until now, the source of these perturbations has remained elusive. The legacy of celestial encounters. The idea of interstellar visitors influencing the evolution of the solar system's planets opens up new avenues for understanding our cosmic neighborhood. While objects like Oumuamua and the interstellar comet Borisov have provided direct evidence that material from other star systems has passed through our own, the possibility of a massive ancient visitor reshaping planetary orbits adds a whole new dimension to the story. These rare encounters provide a window into the dynamics of distant planetary systems, shedding light on the processes that shape worlds across the galaxy. If Brown's theory is correct, it suggests that the history of our solar system is inextricably linked to events that took place light years away, underlining the interconnectedness of the cosmos. Hubble's view of Saturn, a modern parallel. As scientists continue to unravel the mysteries of planetary formation and evolution, modern tools such as NASA's Hubble Space Telescope are providing invaluable insights. Recent Hubble observations of Saturn, for example, have captured exquisite details of the planet's ring system and atmosphere. These images, part of the outer planet's atmosphere's legacy, OPAL project, allow researchers to track changing weather patterns and other changes on the gas giants, providing a contemporary perspective on the dynamic processes that govern these distant worlds. Saturn's rings, which resemble a finely grooved phonograph record, and its evolving atmospheric features remind us that planetary systems are far from static. Instead, they are living, breathing entities shaped by both internal forces and external influences. Studying such processes not only deepens our understanding of our own solar system, but also provides a framework for interpreting the myriad planetary systems discovered around other stars. The wider implications of interstellar encounters. The idea of a massive interstellar object influencing the evolution of the solar system has profound implications for planetary science and astrophysics. It challenges long-held assumptions about the isolated nature of star systems and suggests that interactions between them may be more common and more consequential than previously thought. If interstellar visitors have indeed played a role in shaping planetary orbits, they may also have influenced other aspects of planetary evolution, including the supply of water and organic materials essential for life. Such encounters could help explain the diversity of planetary systems observed by astronomers and highlight the role of chance events in determining the fate of worlds. Looking to the future, as our understanding of the cosmos continues to grow, the search for interstellar visitors and their potential impact on planetary systems remains a tantalizing frontier. Advances in telescope technology and simulation capabilities will undoubtedly shed more light on these enigmatic objects and their role in the grand narrative of the universe. In the meantime, Brown's theory serves as a powerful reminder of the complex interplay between the familiar and the unknown. Far from being a closed system, our solar system is part of a dynamic, interconnected galaxy where even the briefest encounters can leave an indelible mark.